Maybe you've even in a mathematics class seen a proof of Pythagoras' theorem where a squared plus b squared equals c squared for the lengths of sides of a right-angled triangle. You could maybe have gone through a mathematical calculation of that, or maybe you've even seen one of those visual intuitions where they put the squares with the grids on the sides of each of the triangles and they just happen to add up. Now we can understand this intuitive level of proof, but there was always a little bit of a worry that perhaps we're making a mistake. How do you know that you've really proved something? Maybe you've convinced yourself, but there's a little secret glitch that undermines a lot of your reasoning. So one of the efforts to really make this more rigorous was to axiomatize mathematics, which was to basically turn this process of coming up with elegant and intuitive proofs into something that was completely mechanical, something a computer could do, and assuming you didn't write any bugs into the program, it would only return correct answers. So the basic idea is that you have a formal system where you have some axioms. These are things that you take for granted as being true. Now it may sound like it's a bit of a problematic, how do you know what the axioms are? But really think of the axioms as the things that characterize what you want to discuss. So if you wanted to discuss geometry, you would come up with different axioms than if you wanted to discuss number theory or something else. Basically, the axioms are going to tell you what areas of mathematics, broadly conceived, you can explore. Alright, so you come up with some list of axioms. Hopefully it's a small list of axioms, or if there are a large number of axioms, they can be represented by a rule for creating those axioms. Next, you want to come up with some rules for manipulating these symbols, just like you would in a computer program. And then you come up with straightforward rules that if you apply it to an axiom, you get something that's true at the end. Again, this may sound a little complicated, but really we do this all the time. If you've ever studied algebra, you know about, well, if you have multiply by 2 on one side, you can divide both sides by 2, eliminate it on one side, and then have divided by 2, or multiply by 1.5 on the other. This is pretty basic. This is something we learned in grade 7th grade. Algebraic manipulation is very similar to what's happening with axioms and theorems. Basically, what we're doing is we're starting with the axioms, our 1 plus 1 equals 2, or similar types of propositions.
This is our notion of truth. Now, there's a critical mathematical theorem you need to make sense of this, because there's some ambiguity, potential ambiguity in this conception. As I just said, there was one extension, it should be all extensions. Maybe it matters. And the answer is it doesn't. For each sentence phi, whether or not phi is a universal law can be determined formally in each universal generic multiverse. So this does two things. It says it doesn't matter how you conceive of the generic multiverse, as long as it satisfies these two principles, you get the same universal laws. It also says it doesn't matter what meta-universe you're forming the generic multiverse in, because every universe of the generic multiverse will compute the same universal laws. Okay, so you need that mathematical theorem to make sense, to show that this is a philosophical theorem. Now, since the laws can't change past the Cohen blueprint, Cohen's method cannot be used to show that statements are unsolvable in this notion of truth. Now, there are statements that are neither true nor false. Continuum hypothesis is not a universal law. Make it true, make it false. Alright, so we now have three categories of statements. The statements that are always true, those are the laws. The statements that are always false, those are the negations of laws. And then the statements in between. So that's what you give up. Very appealing view. But now we want to analyze this view. I'm worried I'm going to lose track of the time. I see no clock. I have my phone. So, 10 o'clock. All right. So we actually have a hierarchy of laws. So the universal laws of d omega plus 2, that's the power of the fields, are the sentences whose truth in that stage of the universe is itself true in each universe of the generic multiverse. These are the local laws. And then you could define the laws of V omega plus 3, V omega plus 1,000, V omega V sub delta plus 1, where delta is the least inaccessible, and so forth. It's a hierarchy of local laws. These sets of laws are of non-decreasing complexity. If you know the universal laws for V omega plus 3, you can compute the universal laws of V omega plus 2, because V omega plus 2 is definable with V omega plus 3. It's okay, everything looks great, but then something happens. I'm not going to define the omega conjecture, but when you analyze this conception of truth, you're led to this mathematical conjecture called the omega conjecture. It comes out of defining the logic of the generic multiverse. There's a logic for that notion of truth. The universal laws become the omega provable sentences. And the question, you can prove soundness. The question is, you can find a notion of proof. And then the question is whether the analog of the Gödel completeness theorem holds, and that's the omega conjecture. If the omega conjecture is true, then this entire hierarchy collapses. If you know the universal laws for V omega plus 2, you can compute the universal laws for V omega plus 3, V omega plus 1,000, V delta, where delta is the least huge cardinal. The whole hierarchy of local laws collapses down to just the local universal laws of V omega. plus 2. Well, in the philosophy of mathematics, there's another way of saying this. It's formalism. In formalism, you reduce all truth to truth about the integers. This is reducing all truth to truth about sets of reals. Clearly cannot be correct. And it's even worse. So the hierarchy collapses, but each of these local sets of universal laws is definable in V delta plus 1, where delta is the least wooden cardinal. This includes the universal laws of V delta plus 2, V delta plus 1,000. This is clearly not right. It violates the whole transfinite iterative conception of the universal sets. So either the omega conjecture is false, or the generic multiverse option, which seems so appealing, we have to reject. All right, so we made a noble effort. We do some mathematical analysis. We find a conjecture. There's a mathematical case for that conjecture, so we have to give up on this option. All right, so what would the second attempt be? We need to refine the concept of set. So how might we do this? Well, it's got to be that power set operation is the problem. So for each set x, we'll let p def of x denote all the subsets of x which are logically definable in the set x from parameters. And the idea here is if x is a good set, then clearly the subsets of x that you can logically define in x is also a good set. You're not going to get into trouble. So sometimes p def of x is called the collection of simple sets versus the full power set, which is a collection of all sets. All right, so now I want to change. Still going to be looking at the definable sets, but let's go back to the reals. After all, that's where the continuum hypothesis lives. So we'll define a set of reals to be projective if it can be generated from the open sets in finitely many steps of taking complements and images by continuous functions. So the study of the projective sets was a major focus of Polish mathematics in the early 1900s. And how could you restate the projective sets in terms of the definable power set? The projective sets of reals, what I defined here, are exactly the sets of reals that appear in the definable power set of V omega plus 1. Okay. Well, if you're going to look at a complicated problem, sometimes it's good to look at simple cases. So let's look at the projective continuum hypothesis. If A is a projective set, then either A and N, and it's infinite, I should have said, then either A and N have the same cardinality, or A and R have the same cardinality. In other words, if the continuum hypothesis holds for projective sets. Well, unfortunately, the actual constructions of Gödel and Cohen show that the projective continuum hypothesis is also formally unsolvable. So that's very discouraging. That problems occur right away. assume there are infinitely many wooden cardinals and the projected continuum causes a square. So maybe also was. So in particular, in the generic multiverse view, once you have large cardinals, the projected continuum hypothesis is a universal law. And I'm now not as a whole story here. What happened was we now know the correct theory of projective
some tribes, it is assumed that a man has a number of souls. This belief expresses the feeling of some primitive individuals that they each consist of several linked but distinct units. This means that the individual's psyche is far from being safely synthesized. On the contrary, it threatens to fragment only too easily under the onslaught of unchecked emotions. While this situation is familiar to us from the studies of anthropologists, it is not so irrelevant to our own advanced civilization as it might seem. We too can become dissociated and lose our identity. We can be possessed and altered by moods, or become unreasonable and unable to recall important facts about ourselves or others, so that people ask, what the devil has got into you? We talk about being able to control ourselves, but self-control is a rare and remarkable virtue. We may think we have ourselves under control, yet a friend can easily tell us things about ourselves of which we have no knowledge. Beyond doubt, even in what we call a high level of civilization, human consciousness has not yet achieved a reasonable degree of continuity. It is still vulnerable and liable to fragmentation. This capacity to isolate part of one's mind, indeed, is a valuable characteristic. It enables us to concentrate upon one thing at a time, excluding everything else that may claim our attention. But there is a world of difference between a conscious decision to split off and temporarily suppress a part of one's psyche, and a condition in which this happens spontaneously, without one's knowledge or consent, and even against one's intention.